So, welcome back, students. Uh, for this second session, we have already been completed with your this probability distribution chapter. So now we will be starting your new topic, and that topic is movement, skewness, and kurtosis. Okay. So in our previous chapter on probability distributions, we have acquainted normal distribution and its properties. Okay, and we have also studied about this standard normal variate also. So in this chapter, we will learn further how normality or that normal distribution can further be defined statistically. Okay, and this lecture will introduce three more statistical parameters. And what are those statistical parameters? Movement, skewness, and kurtosis. So let us now find out that what these movements, skewness, and kurtosis means. Okay. So starting with the movements, so the introduction of movements. These movements are popularly used to describe the characteristics of a distribution. Okay, how they are being used is to describe the characteristics of a distribution. It represents a convenient and unifying method. That is one and only one method for many things. Okay, and very convenient method for summarizing many of the most commonly used statistical, like measure of tendency. Okay, that is, if you know that how to find these movements, you will be able to find out the value of measure of tendency, then variation, okay, then skewness, okay, and then kurtosis. So one thing, answer to all. Okay, so these movements can give you the values of measures of tendency in the data, variation in the data, skewness in the data, and kurtosis. Okay, so in statistics, movements are arithmetic means of first, second, and so on the rth power of deviation taken from either mean or an arbitrary point of a distribution. So what are movements? Movements are the arithmetic means of first, second, third, and so on rth power of deviation taken either from the mean or an arbitrary point in the distribution. Okay, so in other words, movements are statistical measures that give certain characteristic of the distribution. This I have already told you, and generally in any frequency distribution, okay, any frequency distribution you talk about, okay, so they have four movements are generally being obtained, which are known as first, second, third, and fourth movement. And these four movements describe the information about mean, variance, skewness, and kurtosis respectively. That is, the first movement will give you the mean, second movement will give you the variance, third movement will give you the skewness, and the fourth movement will give you the kurtosis of a frequency distribution. Okay. Then this calculation of movements give some features of distribution which are of statistical importance. And movements can be classified in raw and central movements. Raw movements are measured about any arbitrary point. If a movement is calculated about any arbitrary point, okay, then it is said to be raw movement. Okay, it is said to be raw movement. And if it is being taken around the zero, then the raw movements are called as movements about the origin. Okay, movements about the origin. And when A is taken to be arithmetic mean, we get the central. Okay, so it depends that whether you take a arbitrary point or you take an origin or you take the central movements. So accordingly, these have we got different movements, and they are known as raw movements or movement about the origin or the central movements. So the first raw movement about origin is the mean. Okay, this is a uh, uh, definition. That is, the first raw movement about origin is mean, whereas first central movement is zero. Okay, so we will see that how these definition are being calculated mathematically. So the second raw and central movements are mean square deviation and variance. The second raw and the center movement are the mean square deviation and the variance respectively. Third and fourth movements are useful in measuring the skewness and kurtosis. Okay. Right. So now we will look upon the formula, okay, that how these movements are being calculated. So these movements can be calculated for ungrouped as well as grouped. Okay. So let us first take an example of a ungrouped data. In general, the rth order movement for an ungrouped data about arbitrary point A is given by. Okay. So how this movement is calculated? Mu r dash is equal to sigma I is equal to from 1 to n, okay, is x I minus a power r upon n, okay, where r can be 1, 2, 3 and so on, okay. So this is the movement about any arbitrary, okay. So what is mu r? Mu r is the rth order movement. A is the arbitrary point, R is the order, and N is the number of observations. Okay. If A is equal to 0, mu R becomes movement about the origin. And if A is equal to X bar, that is the mean of the data, then mu R becomes the movement about the mean. So it depends on you that when you are taking A is an arbitrary point, it remains the movement. If A is equal to 0, it becomes movement about the origin. And if A is equal to the mean of the data, then it becomes the movement about the or the central. Okay. Similarly, this formula can also be calculated for a grouped data. And for a group data, this mu r dash is equal to sigma I is equal to 1 k this fi xi minus a power r divided by summation of this frequency or the number of observations. Okay, this fi, and where r is equal to 1, 2, 3 and so on. Okay, so similarly here also n is equal to, only difference is n is equal to sigma this fi, and we have to multiply the frequency into this. Okay, so same as we have given above, if a is equal to 0, then mu r becomes the movement about the origin, and if it is equal to the mean, then mu r becomes the movement about the, okay. Then we have this shortcut method. If we define in shortcut method that d is equal to this xi minus a upon h. Okay. Similarly, this formula can be fit. Okay. So you might have calculated this mean with this shortcut method. Similarly, these movements can also be calculated using the shortcut method. Okay. So the first four movements about the mean are very important. Okay. As mu1 is equal to 0, mu2 is equal to sigma square, mu3 and mu4 helps in the estimation of skewness and kurtosis. Now let us see these things with an example. So this thing will be quite clear. Okay. So we have calculated the first four movements of the following ungrouped data on milkweed from 6 buffaloes about an arbitrary point, origin and mean. Okay. So we have a buffaloes, and these are the 6 buffaloes which are giving 7 liter, 9 liter, 10 liter, 8 liter, 12 liter and 14 liter. Okay. So now we are taking any arbitrary. So let us take an arbitrary point A is equal to 90. I have taken this 9. Okay. So if I have taken this 9, then this x minus A becomes minus 2. 7 minus 9 is minus 2. 9. There is some mistake here. This will be 0. This will be 1. Minus 1. This is correct. This is correct. Only the this will go up and this will go down. Otherwise, other calculations will remain the same. You know, this will go one. Okay, rest things will remain. Okay, so this x minus a will be 7 minus 9 is minus 2. This will be 9 0. Then this will be 10 minus 9 is 1. Then 8 minus 9 is minus 1. 12 minus 9 is 3. And 14 minus 9 is 5. So the sum of these values comes out to 156. Okay. Similarly, when we square them, then the sum comes out to be 40. And if we do them, it is 144. And if we make a power 4, then it comes out to be 1. What was the formula? Formula was like this: x minus a power r. So what will be the first movement? It's power 1. That is, this will come out to be this 6. And 6 divided by number of observations is equal to 1. The first movement comes out to be 1 about the arbitrary point. Okay. Similarly, this mu2, this value was 40. Then this 40 divided by this 6. So it will be 6.67. And this mu3, this value came out to be 144. Then this 144 divided by 6, it came out to be 20. Okay. And then this mu4, so this mu4 is 724. 724, sorry, here it will come 724. Let me see whether um, 12. Well, this 724 divided by 6 is equal to 120.67. 125. Okay. Right. So this is how we can. Oh, sorry. So that, yes. This third movement was 144 only. So this is 144 divided by 6 is 24. And this is the fourth movement. That is 724 divided by 6 comes out to be 120.6. That was that. Okay. So basically, if we take the movements about the origin, that is 0. Okay. So then nothing will be minus, that is 7 minus 0, 7, 9. So these will be the x values. And if we sum them, it will come out to be 60. This is the second movement, x square. Third movement, x power 3. This is the fourth movement, x power 4. So these you will be getting these values. And accordingly, when you divide, you will be getting about origin. So about origin, these will be different from what you have got about an arbitrary. Okay. Now, this is important. That is movement about the mean. So if we take the mean of these, so the mean of these came out to be 10. That is, you sum these up, okay? Or this first movement about the origin is nothing but the mean. That is, if you take these, so this is the sum of the 60, and when this 60 is divided by 6, so it comes out to be 10. So the first movement about the origin of a data is equal to its mean. Okay. So the mean of this data is 10. So if we minus this mean from this data, so these are the values. And first, this value will be 0. Then this is 34. Then when we cube them, it is 36. And then this is 370. Okay. So accordingly, the first movement around the mean is always 0. Second movement is nothing but the variance. If you see clearly the formula, it is nothing but xi minus mu power 2 divided by 6. So it is nothing but the variance. Okay. So the second movement about the mean is variance. Then this is the third movement, it comes out to be 6, and this is the fourth movement, it comes out to be 61.6. So this is how we can calculate the mean about an arbitrary, these movements about an arbitrary point, about an origin, or about an mean. Okay. And we have learned that about origin, the first movement is mean, and the first movement about mean is 0. Second movement is variance. And with the help of this mu3 and mu4, you will soon be learning that you will be able to calculate the skewness and kurtosis measures. Okay. So now we will be learning that what is skewness. Okay. So skewness means lack of symmetry. Okay. What is skewness? Skewness is nothing but lack of symmetry. So in mathematics, a figure is called symmetric if there exists a point in it through which if a perpendicular is drawn on the x-axis, it divides the figure into two congruent, identical. Okay. Identical in all respect, or one part can be superimposed on the other. That is, they become the mirror image of each other. So in statistics, a distribution is called symmetric if mean, median, mode coincides. Otherwise, the distribution becomes asymmetric. And if the right tail is longer, in a distribution, if the right tail is longer, we get a positively skewed distribution where mean will be greater than median. Okay, if right tail is longer, so we get a positively skewed distribution. And there what happens? Mean will be greater than median and median will be greater than mode. If left tail is longer, okay, get a left tail longer, it is nothing but a negatively skewed distribution. And there this thing becomes reverse. That is, maximum will be mode, then median, and then is your. And the example of symmetrical curve, positive curve and negative curve are given below. So this is a symmetry. Okay. And all the mean, mode, median are same. And you can see this red value. You can superimpose this area on this area. So similar area will be on the left side of the mean and similar area will be on the right side. Now in this positively skewed curve, you can see that on the right side the tail is long. Okay. And your mean will be greater than the median and median will be greater than the mode. Whereas in negatively skewed curve, your left side tail will be longer and that relation will hold in reverse direction. That is, your mode will be greater than median and median will be greater than. Okay. So this is how this skewness is work. So variance tells us about the amount of variability, while the skewness gives the direction of it. Okay. So if we talk about these statistical parameters, so variance tells us about the amount of variability in a data, whereas skewness gives us the direction of variability, that is, in which direction the variability is more. And in business and economics series, measures of variation have greater practical application, whereas the measure of skewness is not having that much application. However, in medical and life sciences, the measure of skewness have greater practical implication than variance. That is, we know that variation is there, but we want to know that in which direction this variance is there. More variability is in which direction. Okay, so there comes the role of this skewness. Okay. So what are the various measures of this skewness? So measures of skewness helps us to know to what degree and in which direction, positive or negative, the frequency distribution has a departure from the symmetry. Okay. So this is the skewness. Then although the positive or negative skewness can be detected graphically depending on whether the right tail or the left tail is longer, we don't get an idea about the magnitude. That is, we get an idea only about the direction. So to know an idea about the magnitude, we have to find out some of the measures. Okay. So beside borderline cases where between symmetry and asymmetry may be difficult to detect. That is something lying on a borderline. That how will you define that this is asymmetric or not or symmetric? So hence some statistical measures are required to find the magnitude of lack of symmetry. And a good measure of skewness should possess these criteria. What are those criteria? It should be unit free number. Okay. So that the shapes of different distributions so far as symmetry is concerned can be compared with each other without taking into account the unit. Then, if the distribution is symmetric, the value of measure should be 0. Okay, the measure of skewness should be 0. Similarly, the measure should give positive or negative values according as distribution has positive or a negative skewness. And as we move from extreme negative skewness to extreme positive skewness, the value of measure should vary accordingly. Okay. So the measure of skewness can be both absolute as well as relative. Okay. So there are two measures of skewness. One can be absolute, another can be relative. Since in a symmetrical distribution, mean, median, mode are identical, the more the mean moves away from the mode, larger the asymmetry of skewness. An absolute measure of skewness cannot be used for the purpose of comparison because the same amount of skewness has different meaning in distributions. So these absolute measures, okay, they are used in within a this distribution, not between the different. Okay. So what are these absolute measures of skewness? These can be measured as mean minus median or mean minus mode or these quartiles Q3 minus Q2 minus Q2 minus Q1. Okay. So these are the three measures of skewness. And as you have already studied these quartiles as well as mean, median and mode. So I am not going into calculation of all this. Given any data, you calculate the mean median and accordingly if some value is positive or negative value is coming, so that value is showing that there is some skewness in the data. Okay. And for a symmetric one, it should come out to be 0 because mean and median will be equal to 0. Okay. So for comparing two series, we do not calculate these absolute measures, we calculate the relative measures, which are called coefficients of skewness. Okay. Relative measures. And coefficient of skewness are pure numbers independent of unit of measure. These are dependent on the units. Mean, there is a unit, median, there is a unit. Okay. So what are these relative measures of skewness? In order to make a valid comparison between the skewness of two or more distribution, we have to eliminate the distributing influence of variation. And such elimination can be done by dividing the absolute skewness by standard deviation. So what we generally do, we divide the absolute skewness by the standard deviation to get a relative measures. And what are these relative measures? First one is your beta and gamma coefficient of skewness. So Carl Pearson defined following beta and gamma coefficient of skewness based upon the second and third central movements. These central movements now we have studied. Okay. So if we square the third central movement, divide it with the cube of the second central movement, it will give you the measure of skewness, which is depicted by beta 1. And it is used as a measure of skewness for symmetrical distribution. This beta 1 shall be 0. So if you will be calculating these central movements and if data is symmetric, then you are going to get this beta 1 as okay. Then beta 1 as a measure of skewness does not tell about the direction of skewness, okay, positive or negative, because mu3 being sum of cubes, the deviation from the mean may be positive or negative, but when we square that positive or negative value, it will always be positive. And mu2 being the variance is always positive, so you make it cube, so this beta 1 will always be positive. So this is the one of the drawback, that it will give you this magnitude but will not tell you the direction. So this drawback is removed if we calculate Carl Pearson gamma coefficient. And what is that gamma coefficient? Gamma 1 is equal to the square root of beta 1. So it will be equal to third central movement divided by cube of the variance, and this can be second central movement power 3 by 2. Okay, so if you will take this into account, now your positive and negative value will be reflected, and accordingly you can tell that data is positively skewed or negatively. Okay. Then comes your Carl Pearson coefficient of skew. Okay, and this is nothing but this method is more frequently used as a measure of skewness, and the formula is this mean minus mode divided by standard deviation, as I defined there also. So the value of this coefficient would be 0 in a symmetrical distribution. And if the mean is greater than mode, the coefficient of skewness will be positive, otherwise negative. So the value of Karl-Pearson coefficient of skewness usually lie between plus minus 1. Okay, for moderately skewed distribution. If mode is not well defined, we can use this form. Okay, that is by using this relationship, well, we can calculate this and then define this thing. Or directly, this can be equal to P into mean minus median divided by sigma. But now the value will lie between plus minus 3 for this. Okay. Then there is another Bowley's coefficient of skewness that can be calculated using the quartiles. Formula is this. Then there is a Kelly's coefficient of skewness which can be calculated using the percentiles and deciles. You might have calculated these percentiles and quartiles, these percentiles and deciles when you were studying measures of dispersion. Then what are the features of skewness? Okay, that is fine. If the value of mean, median, and mode are the same in any distribution, then the skewness does not exist in that distribution. Larger the difference, larger will be the skewness. If sum of the frequencies are equal on both the sides, mode, then skewness does not exist. And if the distance of first quartile and third quartile are same from the median, then skewness does not exist. So these can come as true false. Okay, so these things can be given as a true false, and you may be asked that whether the statement is true or wrong. Okay, similarly, if deciles first and ninth and percentiles first and 99 are equal distance from median, then there is no asymmetry. If the sums of positive and negative deviations obtained from mean, median, or mode are equal, then there is no asymmetry. And similarly, if a graph of data becomes normal and when it is folded at the middle and one part overlaps fully on the other, then there is no asymmetry. Okay, so this is about the symmetry of the data and how it is deviated and how the skewness can be calculated graphically, the direction, and using certain measures of skewness, relative and absolute, you can calculate the magnitude. Then there is a short topic about kurtosis, and we will end our lecture. What is kurtosis? If we have the knowledge of the measures of central tendency, dispersion, and skewness, then even we cannot get complete idea of distribution. Why? In addition to these measures, we need to know another measure to get complete idea about the shape of the distribution, which can be studied by the help of kurtosis. Okay, and Professor Karl-Pearson has called it convexity of the curve. Okay, this kurtosis also is known as convexity of curve. So kurtosis gives a measure of flatness of the distribution. What does this kurtosis gives you? It gives you the flatness of the distribution. So the degree of kurtosis of a distribution is measured relative to the normal curve. The curve with greater peakedness than the normal curve is known as leptokurtic. Okay, the curve which were more flat than the normal are platykurtic. Okay, and the normal curve is known as mesokurtic. So normal curve is also known as mesokurtic curve. Okay, so the measures of kurtosis are Karl-Pearson measure of kurtosis. So it can be calculated as beta 2 and gamma 2. And what is beta 2? Fourth central movement divided by second central movement square of the second central movement. Okay, then gamma 2 is equal to beta 2 minus 3. So here mu 2 is the second order central movement of the distribution, and mu 4 is the fourth order central movement of the distribution. So beta 2 is equal to 3 and gamma 2 is equal to 0. When beta 2 is equal to 3 and gamma 2 is equal to 0, then the curve is normal and it is known as mesocut. Okay. When beta 2 is less than 3 and gamma 2 is less than 0, it is said to be platycut. And when beta 2 is greater than 3 and gamma 2 is greater than 0, then the curve is said to be leptocut. Okay, so the figure given below represents the various forms of kurtosis in the data. Okay, so this is a platykurtic, this is mesokurtic, and this is the leptokurtic. When beta 2 is greater than 3 and gamma 2 is greater than 0, and here beta 2 is in this one, platykurtic. Beta 2 is less than 3 and gamma 2 is less than 0. And when beta 2 and gamma 2 are 3 and 0, then this is normal curve of the meso. Okay. Then this Kelly's measure of kurtosis can be calculated using the percent. Okay. And when this beta 2 is greater than 0.26, it is platykurtic. And when this beta 2 in this Kelly's measure is less than 0.2639, then it is known as. So basically, this kurtosis defines you the wickedness in a drug. Okay. And I can see that you have marked your attendance, so we will review them. Okay, that who are present in the second session. Okay. And basically, today we have learnt about this properties of normal distribution, and then this second lecture we have learnt about the movements. Okay, and we learned that the central movements, that is the movement about the mean. These first four movements are very important, and then we have learnt about the symmetry of the curve, this normal distribution, that